So in solving this inequality then, we want to figure out where the boundaries are. So that's going to be the key idea. So I want to factor this. So I have x plus 6 times x minus 2 is less than or equal to 0. So there's a few different ways I can solve this. The keys still remain the boundary point. So I have boundary at negative 6 and positive 2. I'm going to include the boundary, so I'm going to fill those in. Okay, being a one variable inequality, I know that my solution is going to be along the number line. And if I want to visualize this, I can think of this as a parabola that is facing up that goes through those zeros. And what part of this parabola am I really looking for? I'm looking for where the calculations are bigger than or equal to 0. So that would represent these outside pieces. Okay, so visualizing the graph allows us to determine that we're really looking for these two sections here. Okay, so that's one strategy. The other one is we can actually test. We can just test some boundary positions. So I'm going to test. The easiest number to always test is going to be 0. So if I test x equals 0, I end up with 6 times negative 2 is greater than or equal to 0. Negative 12 is not greater than or equal to 0. So that represents a no solution position. That means then there's a good chance it's likely the solution on the other side. So if you're not sure, we can test x equals 3. So I end up with 9 times 1 is greater than or equal to 0. 9 is greater than or equal to 0. That's okay. So then that represents a solution region on that side of the number line. And again, we can test some position to the left of negative 6. Negative 7, so I end up with negative 1 times negative 9 is greater than or equal to 0. 9 is greater than or equal to 0. Yep, that is the solution portion. So by testing the boundary regions, I can also establish the solution to this inequality. Again, I think visually, if you can visually understand this through above and below the x-axis, that is a good way to determine the boundary, the areas of the number line which represent the solution areas. So here we can graph this. Let's go ahead and graph this one here. We've got a graph, and if I show this graph, it looks like we're going to have a solution at x equals 0. Okay, and it looks like x equals positive 2/3, okay, is going to be another boundary point. Okay, so they're going to cross at those points. Okay, and actually I'm not going to do those circles there, because I should show those on my number line. So it's going to be empty circle here at 0 and at 2/3. Okay, I'm going to have an empty circle here. Okay, so then if I graph this, my graph is going to look like this. It's going to be a parabola opening down. Okay, and then I have to establish which part of this parabola am I looking for. Okay, so I'm looking for parts of this parabola that's going to be greater than or equal to 0. Or sorry, greater than 0. Well, greater than 0 is going to be above the x-axis, so it's going to be this region here. So there's my solution region based on my graph. I can test this still. Okay, so I could use more than one strategy here. So I'm going to test x equals 0.5. When I plug in x equals 0.5, I get 0.25 times negative 3, so negative 0.75. Plus 1 greater than 0, yeah. 0.25 is bigger than 0. That is a correct position if I substitute in 1/2. 1/2 represents part of my solution. So putting this one into my graphing tool, I'm going to end up with 2x squared minus 3x minus 10 is less than or equal to 0. So I'm going to get my Desmos out here. and I'm going to put this into my Desmos, and I'm going to see what this looks like. So this should be a parabola facing up. Okay, so I end up with 2x squared minus 3x minus 10. Okay, so I end up with a parabola that goes through somewhere around there, kind of goes down, and then comes up through here. Okay, so if I look for my roots here, I have 2 roots. Okay, now my Desmos shows me that these are irrational, so I probably should show them as exact values. I'm just going to show the decimal values for now, because sometimes it's okay to give decimal solutions, but we should always try to get exact value solutions. So I'm going to put those points in here, and we're going to include those points. I'll do the analysis first, and I'll get the exact values after. So what am I looking for? Well, this inequality says I'm looking for less than, so I'm looking for this portion below the x-axis. So the region between the 2 zeros then represents my solution region. Okay, and again, I can test x equals 0 would be a convenient position to test because it's in between. When I test x equals 0, I get negative 10 is less than or equal to 0. That works. That's okay. That's the boundary reason that we want. So then the last thing here, and again, I do have the decimal values, but again, we do aspire to have exact values. So I'm going to use my quadratic formula to get the exact values. So I get b squared minus 4 times a times c all over 2 times a. So I get 3 plus minus. That works out to be 80, so square root 89 all over 4. So this position here is going to be 3 minus square root 89 divided by 4, which is a negative value. And here I get 3 plus square root 89 over 4, and that's going to be my 3.108. This position here is going to be my negative 1.608. Okay, so there's my solution. Graphing is going to be the easiest because what we're looking for then is in a one variable situation, we're looking for above and below, and our solution is a one-dimensional solution on the number line.